Hello. Did you know that there is a tool that can make the most amazing V-carves? It works flawless, it's very easy to use, and it's part of a program that you wouldn't expect to make G-code for the CNC. I'm talking about Blender and the FabEX CNC add-on, which is totally free. They are both open source, so you can just download them and install them on your computer. In this video, I will walk you through the process of generating the G-code, of importing an SVG file with my logo. The best thing that I can do is show you how it works, how it does the V-carve, and of course, show you how to program your machine, how to use Blender together with FabEX CNC to generate the G-code to make absolutely stunning V-carves for any project that you want. Just as in any other CNC project, the toolbit is really important. I'm using a very high quality toolbit, and you will be able to see how great results I can achieve using this type of toolbit and this software that can V-carve, that can engrave almost any project that you might think of. A lot of you might have problems fitting the workpiece to the table if you don't have a vacuum table. I don't, obviously, and I want to show you the easiest method, especially when engraving things. Attach the strips of double-sided tape to the table. And carefully align the piece of wood to the table, trying to keep it as perpendicular as possible to the axis of the CNC. Now let's set the Z0 to the top of the material, because that's the way I'm going to do the things today. So place the probe on the table, attach the clip to the toolbit, go to the probe module and click on the probe and 0Z button. So the first part is ready. I'm going to stop the air blower and I'm going to clean it a little bit so I can show you how it turned out after the first step, which didn't include removal of the material in the center of larger lines. I just wanted to show you that even though it might seem a very fuzzy cut, it's actually just sawdust trapped into the holes. And that is because this is a toolbit that has a small downcut angle, which means it will push the material to the bottom. This is great because it leaves these beautiful edges. It doesn't tear them apart when cutting. In order to create that very nice toolpath that you have seen in action, I'm using Blender 4.5. You also need to install the add-on, the FabEX CNC add-on, and here you have a guide, a video guide. You will see how to install everything in Blender 4.3, but the same applies for this version, so I'm not going to repeat that again. Now let's import the logo and create the toolpath. Go to the File menu, Import, and select Scalable Vector Graphics. Go to the folder where I have the logo, select the file, click on Import SVG. It's just as easy as that. You can see it here. Everything looks almost exactly as I need it in order to create the CNC operations. If I take a look at the right in the tree, I can see that each of the objects in this SVG file is a separate path, which I don't want. It complicates things a little and it will generate some problems, so let's make them only one object. Click, hold the mouse button, drag to select everything, to touch everything. After selecting them, press Ctrl J to join all of them into just one curve. You can see it here, it's called path 5. Now that we have created a single object, let's resize it, let's bring it to the correct dimensions by pressing the N key or this little arrow here, which I cannot properly select with this mouse pointer. But let's press the N key and I have the menu open. Well, I have just the side menu because the CNC doesn't have anything in it right now. Let's go to item because that's what we want. Let's check the dimensions, which is 223 millimeters by 105. I want the logo to be 200 millimeters wide, so let's scale it. To scale it from 223 millimeters to 200 means a very specific number which I would have to calculate. Luckily, Blender helps me with that because I can simply write 200 divided by 223, press enter, and I have the correct scale on the x-axis. Now let's copy the same value. You can see it has 6 decimals. Let's copy the same value on the y-axis. And now it looks again proportional, everything is correctly set up, the dimensions are correct. I just need to do one more thing, take the mouse over the object, press Ctrl A to apply all the transforms, and now the scale is at 1 with the new dimensions. Everything is set up now. Let's go to the CNC tab and see how to create the operations. Why is the CNC tab open? Because I don't have the proper render engine selected. So let's go to render, scroll a little bit up and change the render engine from whatever it was by default to FabEX CNC CAM. Let's set up the machine first, scroll down to the machine group. Let's take them one by one really quickly. The post processor means the language that the G-code will be exported. I'm using GRBL. If you're using a different machine, select the proper one. The same applies for the unit system. I'm using metric. The next values, the collect size and the work area, depend on your machine, so set them up accordingly in order to avoid having some problems if the object is too large for your machine. I still need to change a few things. Go to the feed rate group, open it and set a default feed rate, a minimum and a maximum feed rate. If you don't set the maximum feed rate according to your machine, let's say it is set to 2000 millimeters per minute, no matter how high you set that number in the operation, it will be limited to this value. So that is why it is really important to set the maximum feed rate that your machine is capable. The same applies to the spindle speed. You need to have a maximum which is valid for your machine, otherwise any value set higher than the maximum will be reduced to the maximum. And that's all we need to set up for the machine. Now let's create the V-Carve operation. Make sure you select the object either in the tree or in the 3D view. Click on the plus button in the operations group. I have this part of the screen filled with all the information that I need to set up to generate the G-code. First, let's change the strategy from profile to medial axis. This is how V-Carve is called in Blender. I will leave the add pocket option checked because for these areas the cutter head is too small. It won't be able to make just a V-Carve to generate this drawing, so I need to also remove some material left in the middle, and you will see in just a couple of seconds what I mean about this pocket. The safe height of 10 millimeters is okay. The operation depth is at 0 millimeters and it will go down to the object, to the position of the object. But my object is positioned at 0 millimeters, so it won't mill anything. Let's change that by going to the item tab, go to location and type -5 here, press enter, and now the object is lowered to -5 millimeters. I can go back to the CNC tab and continue setting everything up. If you're milling something very deep, I recommend using layers and setting a layer height according to the tool bit, otherwise you might end up with some problems, the cutter head not being able to cut everything. I will uncheck this because my object is at 5 millimeters deep, so I don't need any layers. Let's set the cutter. I won't select any preset, but I will set all the values manually. Let's change the type from end to V-Carve. I have an angle of 30 degrees for my V-bit and a diameter of 6.35 millimeters, a quarter of an inch. It has two flutes, but this doesn't really matter. The tool number is valid only if you're using several tool bits, so I can leave everything exactly as it is. For the feed rate, I will first go with the default of 1000 millimeters per minute, but I will change the spindle speed to 18,000 RPM to get a smoother finish. And there's just one more thing that I need to change in order to have a working file. Of course, we will modify it a little bit later to make everything run faster and better. But what is really important is to check the output trailer option and write M02 here. Why is it important? Because if you don't do that, the spindle won't stop at the end of the program. You need to stop it manually. It's pretty annoying. Maybe you're doing something else. So remember to check the output trailer option and write M02 here. Since this is a V-Carve, the climb or conventional milling type doesn't really matter because it will cut conventional on one side and climb cut on the other side of the tool bit. So no matter how I set it up, it just switches these two sides. This is all that I need to set up. I can now generate my first G-code for this log. In order to do that, go back to the right and click on the Calculate Path and Export G-code button. Well, it's called wrong. It's not going to export the G-code, only calculate the path. You can see the G-code has been generated. Let's select it so it is highlighted. It will mill the center of lines that are less wide than the tool bit. For lines that are wider than the tool bit, it will mill the outside and it will leave some material unmilled in the middle. It's more obvious on this part of the design where you can see it goes on the outer edge, but the material in the middle won't be milled. Before showing you how to also remove that material, let's export the G-code. Then let's take a look at how things work out for removing this material. And in the end, I will explain how to set up the operation to get that result. In order to be able to export the G-code, I first need to save the file. If I don't save the file, everything will be saved in a certain location based on the Blender installation, but I don't like to look for files like that. Let's save the file and the G-code will be saved in the exact same location. Logo vcarve.blend. And now let's save the file. Before doing that, I will go here and rename the operation and the file name. Let's call it V-Carve outline and do the same for the file. Now I can click on the Calculate Path and Export G-code button again, which I remind you, it won't actually export the G-code. But after recomputing everything, I will have the button to export G-code instructions. Here is a button, click on it, and now the file has been created in the same folder where I saved the Blender file. I can now go to Universal G-code and load it, and you have already seen how it works. Now let me show you how the Medial Pocket, the removal of the extra material works, and then I will show you how to generate the G-code for that. So we are back, you've seen it in action, there's a lot of movement, but it doesn't actually take that long. You could also switch to another tool bit, but this will result in other problems in the corners. Let me show you how to set the medial pocket so it works pretty fast and gives you great results. When creating the V-Carve outline operation, it automatically created a new operation medial pocket, also the most important thing, a new object, the medial pocket. You cannot see highlighted because it overlaps with the toolpath of the V-Carve. Now you can see the medial pocket. It is a curve that represents all the material that couldn't be milled using the V-Carve operation. The medial pocket operation is an operation based on this curve which will remove the material from this area. Let's set things up in order to get the results that you have just seen. Change the type from perimeter to parallel, change the angle to 90 degrees, and check the contour finish. Set a step over of 0.2 millimeters. For the operation area, I will leave everything just as is. It has been automatically generated correctly. Let's go to the tool bit. Again, select V-Carve. Set a cutter angle of 30 degrees. In my situation, if you're using a different tool bit, of course, use a different angle. And here is the little trick that I'm using. I'm not going to set the diameter of 6.35 millimeters. Instead, I'm going to use the diameter of the tip of the tool bit, which is 0.2 millimeters. Now scroll to the spindle speed. Let's set a spindle speed of 18,000 RPM. Leave the feed rate just as is for now. Check the output trailer again. I remind you this is really important so the machine stops when the operation is finished. One more important thing is the milling type. Change it from climb or conventional or whatever it is. Change it to meander, which will reduce the time in half. It won't cut from left to right, let's say, then lift the tool bit, go back to the left and so on. It will cut on both directions. When moving left and then when moving right, it will cut. This means the overall time will be reduced in half. That's all I need to set up here. I can again click the calculate path for this operation. And you can see it highlighted all those small lines one next to the other, which left that perfect finish for the bottom of the pocket. Of course, you can experiment with various settings, maybe go to the step over and increase it, but I discovered that these settings work okay for me without wasting too much time in order to get the correct shape of the V-Carve. I'm going to use a small brush and some contrast thinner. I have to admit that I've never achieved such a beautiful V-Carve until I discovered Blender, the FabEX CNC add-on, and of course this great toolbit that works absolutely amazing. I will expand this panel a little bit so I can show you how to optimize things both for the V-Carve outline and for the medial pocket operations. You have seen the optimized version, and let me show you each of the settings that I have changed, explain you why I did that, and let's see how much they affect the total time. You can see here on the left, let me scroll a little bit, the estimated time of the operation. So let's take them one by one. The V-Carve outline takes 12 minutes and 57 seconds, and the medial pocket 22 minutes and 42 seconds. Let's improve this first for the V-Carve outline. If I take a closer look, I can see that I have a lot of going up and down of the tool bit. Since my piece is attached to the table using double-sided tape, let's change that to 2 millimeters because it is high enough in order to avoid touching the material, but also to avoid a lot of useless travel up and down. Let's calculate the path again and see what difference is from the 12 minutes and 57 seconds estimated for the initial setup. All of a sudden, by just changing that height, the safe height, the time has dramatically decreased to less than half, 5 minutes 59 seconds. Let's take it even further and modify some other things. Here I have the feed rate, which is the default 1000 millimeters per minute. If your machine can handle more, try to use a higher feed rate because it will also reduce the milling time. In my situation, I'm going to use a 2000 millimeters per minute. The machine can do more, but I think it will affect the finish, so 2000 is the limit in my situation with this tool bit in this type of material on this machine. Let's calculate it again and see how much time we are going to save using this fill rate improvement. So from 5 minutes 59 seconds, now it's 3 minutes and 5 seconds. Again, a huge improvement, but there is still one thing that I can improve in order to save some extra time, which is the plunge speed. By default, it is 50%, which means the speed on the Z-axis is going to be 50% of the fill rate, 1000 millimeters per minute. I can, without any worries, increase this to 100%, so it moves also with 2000 millimeters per minute. Now let's recalculate it and you will see why everything worked so fast in the first part of the video where you've seen this operation in action. So another minute saved. Now the total time of this operation is 2 minutes and 3 seconds. In the beginning, with the default settings, it estimated a time of 12 minutes and 57 seconds. I've been able to reduce it to just 2 minutes and 3 seconds by changing a couple of settings. Now let's move to the Medial Pocket operation to make the same settings, to modify them. So the safe height, let's bring it to 2 millimeters. Scroll down, change the feed rate to 3000 millimeters per minute. This time I can use a higher value because it won't mill any edges which I need to look perfect. It will just remove the material in the center, so I can use an even higher rate than for the V-Carve. Let's also change the plunge speed to 100% and let's take a look. For now it estimates 22 minutes and 42 seconds. Let's recalculate the operation and see how much time we are going to save by modifying these settings. The total time now is 5 minutes 59 seconds. Together with the 2 minutes and 3 seconds in the first operation, the entire V-Carve will only take me 8 minutes for a 20 centimeters by 10 centimeters logo V-Carve. This is why I love Blender and I love using FabEX CNC for any V-Carve operation. It is really powerful. It can handle objects that are wider than the tool bit. It handles pretty well combined SVGs. It does it fast. It does it with a really good quality of the toolpath. And if you combine that with a really good tool bit as I used in this video, you will get incredible results without any need for further finishing. Thank you for watching. Don't forget to subscribe, and if you want to support me, subscribe to my Patreon page. You can find the link in the description. You will also get access to a lot of other files that you can use, and you will be able to watch all of the videos without any interruptions. Thank you for watching and see you next time.